we will see now this question. So what this question is, what this question says is, consider the situation shown in figure. Both the pulleys and the strings are light. Okay, so both pulley and string are light. All surfaces are frictionless. Find the acceleration of the mass m. So this is mass m. Find the acceleration of the mass m. This is mass m. This is mass m. Find the tension in the string. Calculate force exerted by clamp on the pulley in figure. Okay. So first we will see, since the string is getting pulled, so we will first find the constraint relation. So for finding constraint relation, suppose this is distance is, suppose we write xa or x1, this we write x2. Okay. So if we see the length of this whole string, this will be how much? This will be 2x2. Why 2x2? Because x2 here and x2 here. So 2x2 plus x1. 2x2 plus x1 is the total length of a string. Now if you differentiate it, you are going to get 2v2 plus v1 equal to 0, or 2a2 plus a1. Again differentiating again. So this we are getting after differentiation. After differentiation. So we have already done this kind of things. So we are getting what? We are getting a1 as minus 2a2. So what does it mean? So a1, so this is a1 corresponds to this hanging object. So if this object is going down with acceleration a, suppose, okay, then acceleration of this one will be half. Actually a2 is half of this. Okay, so if this one is going down with acceleration a, this object will slide leftward. See, if it is going down, this will slide rightward. This will slide rightward with acceleration a by 2. You can see this is related with a by 2. So this object B will slide rightward with acceleration a by 2. And if B slides rightward, the block will also slide rightward with same acceleration, because this is directly attached. Okay. Now this is constraint relation. Now we will write force equation. So for M, if we write, what are the forces? This is downward force, capital Mg, and there is upward force, tension. Okay. So for capital M, if we write, there is, if you pull it downward, so Mg downward minus tension upward. This will be equal to capital M into acceleration A. We have assumed its acceleration A. This we can write as equation 1. Similarly, if we write for second object, so one thing we can see here is, if tension here is T and this one is T tension, okay, if this one is tension T and this one is also tension T, then this one becomes tension 2T. I have already discussed that around a pulley, if you have this kind of system, if two tensions are T and T, then this is T. Okay, so these two tensions are T and T, then this tension will be 2T. So in this way we can write. Okay, so this tension is 2T. So the 2m mass is getting pulled by tension 2T. Like this. This is getting pulled by tension 2T. So what we will write? See, we have other forces also. We have this weight 2mg, and we have another normal force from the ground, that is N. So for, if we write the free body diagram for 2m mass, we can write tension 2T, and we can write 2mg, and we can write normal. Okay, these are the three forces, but normal and 2mg will balance each other. Only 2T is going to give some acceleration. So 2T is equal to mass 2m into acceleration. So how much is acceleration? A by 2. So we can write like this: ma, this is m, this is a. So f equal to ma. Now we can write t equal to ma by 2. So this much we can write. Now we have to solve these two equations. So this is equation 2. So we can replace the t in the first equation, or we can add this to add equation 1 with equation 2. If you add these two, we are going to get capital Mg minus ma by 2 equal to ma Okay, now if you take ma by 2 on the other side, so mg equal to 3 or ma plus ma by 2, so that is how much? 3 ma by 2. So cancel, so a we are getting as 2g by 3. So a which we are getting is coming how much? 2g by 3. We are getting 2g by 3. Okay, so this is the acceleration. Now what other things are we need to find? So find the tension in the string. So tension in the string, if we say tension is ma by 2. So m by 2 and a is 2g by 3. So we are getting mg by 3. So we are getting mg by 3 as the tension T. And here in the other, this one, you will have double of this value. In this one, the tension will be 2 mg by 3. In this string, the right string, the tension will be mg by 3, and the left string, the tension will be 2 mg by 3. Okay. After this, we need to find the force exerted by clamp on the pulley. So if you look at the clamp, what is happening at the clamp? So in clamp, if you see, this is the clamp. There is a string pulling the clamp in this direction. There is another string pulling it like this. See what is happening at the clamp. This is clamp. This is clamp, and this one is pulley. So this clamp and these two tensions and pulley are connected. So on pulley we have how many forces? On pulley A. On pulley A, if we say, what are the different forces acting? On pulley A, if we say the forces are the clamp force, suppose R we say, and T. These two tensions are acting, and there is no mass for the pulley because we always assume the pulley is massless. So how we can find the value of R? Okay, so these two are perpendicular, you can see. So this T and T are perpendicular. So the summation of these two will be T square plus T square under root, and this magnitude must be balancing the R. Only then there will be net force 0. Okay, so why we are writing this? Because this is in equilibrium. The pulley is in equilibrium. Pulley is in equilibrium. Equilibrium means no force. Okay, so if we write there, we can write R equal to root 2 T. Okay, so how much is root 2 and T is mg by 3. So this will be the answer. So you can see, you can find for force on the pulley, force on the string, and that string is deciding how much force will act on the clamp.